with radicals in this unit. So if it says, evaluate the following function if possible. It says find f of 7, what would I do? Plug in 7 into s, so that would be the square root of 9, which is 3, right, everybody?
Yeah.
Okay, f of 10, that would be the square root of 12, which would break down into 4 times 3, 2 times 2, so wouldn't that become 2 root 3? And so on. We get the picture here, right? We know how to plug things into functions. We know how to simplify radicals, so we know how to do these type of problems. Okay. Okay, graphing root functions. So
We can do this, guys.
I just do not understand. Okay, graphing root functions. Let's say I started at -1. The square root of -1 is I. We can't start at -1, right, everyone? Can we start at 0? Yes. The square root of 0 is, square root of 1 is, square root of 2 is a decimal. I'm only going to graph whole number points. So I'm not going to graph that one. Square root of 3, square root of 4 is square root of 5, 6, 7, 8, 9. So then I can plot. I have enough points. So watch. 0, 0, over 1 up 1, over 4 up 2, right? Then over 9 up 3. So here's my square root function. Notice a square root function is a sideways parabola that's just the top half of the parabola, right? Okay, looking at this graph, I need to make a connection here so this upcoming part is not so hard. It's been hard for people today. What is my domain based on the graph? Left and right is domain, thank you. So we go from 0 to infinity. So I write it like this. 0 is included because 0 was in the domain. 0 to infinity. Now we have to write it also in interval. This is interval notation. We also have to write it in inequality notation. So aren't those the x values greater than or equal to 0? Right? Look, x values that are greater than 0 or equal to 0. Now watch, I need to make a connection here. Doesn't under the radical have to be not negative?
Yes.
So isn't it true to say under our radical needs to be greater than or equal to 0?
Wow.
So you could get the domain without even graphing it, right? Okay. So now what's our range? If we have the graph, they're only going to ask you range based on a graph. So they will not just say what's the range, but they will ask you the domain without having to graph it. But if they ask you range, they'll say graph it first. So our range is 0 to infinity. Now watch. That would be like this. Our y values are greater than or equal to 0. Because range is y values. Pretty easy stuff.
Wait, so what did you mean like with how you have to graph it? Like,
If I said to you, given this function f of x equals the square root of x, what's the domain? You'd say, well, under our radical has to be greater than or equal to 0. True? So the domain is x values greater than or equal to 0.
oh, okay.
Okay, looking at this one, let's make a connection here. Just looking here, what's the shift, if you can remember from last year? Right 2 units. Now everyone look, if I plug in 0, that'll be -2 underneath. We can't start at 0. If we plug in 1, that'll be -1. We can't start at 1. We're starting at, can I plug in 2?
Oh, yeah.
What's 2 minus 2?
0.
The square root of 0 is 0. So aren't I starting at 2? Well, look at the connection. Right 2, isn't that the starting point? Right 2. So that will help me know which is my first point to start with. Okay. So if I plug in 3, that would be the square root of 1, wouldn't it? Look, 3 minus 2. So then plug in a 4, square root of 2. So we're not going to plot that one. Plug in a 5. We get the square root of 3, so we won't plot that one. If we plug in a 6, we would get the square root of 4, which is 2. So look, we have 2, 0 on our graph. We have 3 up 1. We then have 6 up 2. And I have now a graph here. Okay, let's do the domain. Domain is?
Just memorize like the way the travel's going. It's going in the same pattern.
It's
up 1 over 1, up 1.
No, I would prefer, they want you to just plot points. I would prefer you not memorize that. 2 and 0, right everyone? 2 to infinity.
Yeah.
So you'd say this, x values that are greater than or equal to 2. Isn't that true based on the graph? Now look how that's related. So in the future, this is easy for you. Isn't it true to say what's under our radical has to be bigger than 0? So what's under our radical, x minus 2, needs to be greater than or equal to 0. Isn't that the true statement? Add 2 over. So x must be greater than or equal to 2. Do you see how they relate? We found it with the graph, but we could also find it with algebra. So then our range, isn't it still 0 to infinity? So y value is greater than or equal to 0. Okay, we're doing good. Okay, I won't go through this whole thing if you can at least tell me where I would start. So what's the shift? Left 3. So what would be my first point? Negative 3. Are we understanding what's going on? Doesn't it usually start at 0? Shifting left 3. Negative 3. Are we good? I teach college classes for a reason, so I don't have to build this. Are we good? Are you sure?
Yeah.
Okay. All right, so then I would plug in and we'd just go for it, but I'm not graphing it. So what's the domain? You guys see why she's saying that?
Yeah.
She's saying under a radical needs to be larger than or equal to 0, which is a true statement. So then subtract 3, subtract 3. So x value is greater than or equal to negative 3. So then, if that's true, wouldn't it be starting at negative 3 to infinity? X value is greater than or equal to negative 3. Are we good? Range would still be 0 to infinity because it didn't shift up and down at all. All right, let's go on to cube roots. Cube roots are very different than even roots, like square roots. Cube roots, we can plug in positives and negatives. There isn't restrictions on cube roots, if you can remember. Can I plug in 0? I get 0. Can I plug in 1? Cube root of 1 is 1. Can I do the cube root of negative 1? Yes, it's negative 1. Cube root of 2 is a decimal. 3, 4, 5, 6, 7, 8. Cube root of 8 is? So the cube root of negative 8 is? Negative 2. So the domain is, I can plug anything in. Our domain is all real numbers, right? I can plug anything into odd roots. So I plot it 0, 0, 1 up 1, negative 1, negative 1, over 8 up 2, over negative 8 down 2. So it's a snake, right? Cube roots are snake graphs. So then my range on this one, guys, would also be all real numbers. It's growing down and up forever. It's growing left and right forever. Now picture me taking this and shifting it. Isn't that going to not change the fact that it's going left and right forever? So, and if I shift it up and down, that's not going to change the fact that it's growing left and right forever, or up and down forever. So no matter what, it's the domain and range for cube root will be all real numbers. So let's see. Let's test your knowledge. What's my domain? All real numbers. What's my range? All real numbers. Okay, so it's been shifted up 2, right? This is added on the outside. That's not going to affect anything because look, under our radical is just cube root of x. So can I plug in 0? Cube root of 0 is 0 plus 2 is cube root of 1 is 1. 1 plus 2 is cube root. What should I plug in? Negative 1. Cube root of negative 1 is negative 1. Negative 1 plus 2 is 1. So then negative 8 and 8 will be my other two, right? Cube root of negative 8 is negative 2. Negative 2 plus 2 is 0. We're almost done. Cube root of 8 is 2. 2 plus 2 is 4. And then I plot the points.
What did you skip the
Because that would be the next whole number. Like cube root of 2 would be a decimal. 34%. Good question. So over 8 up 4. And then over negative 8, 0. So look, there's our S. It's just been shifted. But our domain and range did not change. Okay, I'm not going to graph this one as long as you can tell me what my domain and range is. And my range? And then wouldn't I just plug in, look, under the cube root, so wouldn't I just plug in 0, 1, negative 1, 8, negative 8, and then just calculate it? Yep. Okay, awesome. Okay, awesome. So now let's use our knowledge to, if I just said to you, find the domain without graphing, we just saw how to do it with graphing. I think we all understand. So right here, what would be my true statement? X plus is greater than or equal to 0, because under the radical cannot be negative, but it can be 0. Okay, so then you just say x is greater than or equal to negative 6. So then it would be negative 6 to infinity. Okay, let's do this one. Find the domain. So what would we say? 2x minus 5 needs to be? So then you'd add 5 divided by 2. So x is greater than or equal to 5 halves, right? So then you'd say 5 halves to infinity would be our domain. Okay, even roots, that is true. Even roots can't have negatives, so our true statement here, this one I'm doing for a purpose. 6 minus 3m, doesn't that need to be greater than or equal to 0? It's an even root, so we can't have negatives. So then solve. Just a reminder, with an inequality, negative 3m is greater than or equal to negative 6. If you divide both sides by a negative, you have to change the sign. So m is less than or equal to 2. Now it says m values less than or equal to 2. So that would be negative infinity up to 2, because below 2, right? There's our domain. But what about odd roots? What would my domain be with an odd root? Can't we have negatives? Positives? 0? Yes. So what's the domain? All real numbers. What's the domain on this one? All real numbers, because they're odd roots. Are we good? That's the end of the lesson. Okay, that's the end of today's lesson. So you have 40 minutes. I want you working on math.